Welcome everyone to this online platform. Since COVID changed everything in Miami, we moved away from our in-person meetings initially at Hibiscus Gallery in Pinecrest Gardens, then at Books and Books, and then back to Pinecrest Gardens, where we thought we were going to build a very engaged way of communicating. In fact, those meetings involved people, including Sila, who's in our room today, literally painting yard signs of the Underwater HOA numbers. Unfortunately, March came and we had to turn everything back into this format. This format has, as everything in our world, has proved to have silver linings. And one of the most important silver linings I've discovered is that, thanks to our chair, Brian, and the team, including Jamal and Adam, we bring really relevant, timely, and important experts like the guest speaker that Brian's going to introduce tonight, Dr. Cairo, to give us information that really does what I think this homeowners group did. And Dr. Cairo, just as a way of inviting you to the meeting, let me explain what this is. You are smack in the middle of an engaged data visualization project. What we did is we mapped the topography of our community, but in an engaged way that gave people even more and more sense of ownership and curiosity to effectuate change. That engagement was so strong that 18 months later, through a pandemic, we still have individuals who come on a monthly basis to participate. And the project has taken a series of iterations, but this is literally an art exhibit for Art Basel Week of 2018. And here we are, an Art Basel Week of 2020, right? More than 2 years later, because it started in the summer of 2018. We are still working and being relevant and doing timely things like creating underwater vote installations to tell people to vote the right way when it comes to climate. It's important for us as an organization to continue meeting, albeit in different ways. I don't think we're going to be able to come together and have that synergy, that person-to-person esprit de corps, probably until middle to the end of next year. We don't know how the vaccines are going to happen, but we just left Thanksgiving and, we have a total of 3,860 Miamians who have passed away because of this pandemic. And we are being as thorough and respectful as we can to make sure that we do not in any way model risky behavior by bringing people into a room, even if they wear all their protective gears when it's not necessary. So that is why we have this format, and I'm adamant about keeping it that way. The second reason I think it's relevant is because all that knowledge that normally happens at that interpersonal level, when you're sort of just having a conversation with someone, gets a little bit diminished here because there's structure, right? Not everyone can speak at the same time. It's not like we can go to a little room and talk and come back. So the nuances of that very important interpersonal conversation are diminished, but what is amplified, I think, is the sense of purpose and the recorded history of what we have been doing now for 2.5 years to address the challenge of our time. And as I'm sure your PowerPoint and your words are going to describe, and as our chair, who is the chair of ocean sciences at the Rosenstiel School, can attest, climate change, human-caused climate change, is impacting our city, making us try to address issues that are unthinkable, like even in the future, climate migration from the Caribbean here and from here to other locations, think that are essential. Again, Brian, our chair, in his capacity as a professor, and I were looking at visualizing the impact of hurricanes and the work that he's doing at his SUSTAIN lab, and looking for communication students. I'm sure we'll come to you at some point to ask you to give us your best and your finest to be able to have our community understand the science behind it, understand the public policy and the impacts. And as you and your life work has demonstrated, being able to visualize that is important. What we love about our present day of visualization is that we have to have more engaged, and you were just talking about that at the beginning in your conversation with, I think, Wayin or someone you were talking to, about how what you try to do is a more engaged way of visualizing data, and one that piques curiosity. So you are in a very good home because this Underwater Homeowners Association is literally about doing that, by painting intersections with the elevation of those intersections, but having people paint them, not me paint them, by making our own yard signs, as our board member and executive committee member Holly did here in leading her South Miami neighbors in a park to literally hand paint the signs, as Adam has done with a cadre of University of Miami students who have done the same kind of work. We're really about engaging one another. That engagement leads to being curious, and what you're about to present, as you know, this dozen speakers before you, are new ways of seeing and new ways of thinking. My hope is that once we get out of this pandemic and we're ready to grow this program, your words, your video, your slides are part of a museum exhibit, are part of a website resource page, are part of, again, motivating and giving people the tools for them to warn their neighbors that they should care at least as much as they care about an incoming hurricane, which comes and goes, as they should about sea level rise, which comes and stays. And there will be no FEMA to solve our problems when sea level rise happens, because it's going to happen not at one point like a hurricane does when it hits a city, but at every point and at the same time. So that's my way of welcoming you and giving you a sense of who we are as a homeowners association group. And if I could just now pass the gavel to our chair, who can introduce himself a little bit, and and maybe Holly or something, and then obviously introduce you as a way of having you lead as a keynote. Thank you so much, Dr. Cairo.
Okay, thank you, Xavier. Brian House, and the chair, as Xavier mentioned, and I appreciate the opportunity to welcome Alberto Cairo here. I'm one of the people that probably know you. I know there's a number of people that know you quite well in this Zoom, but I'm not one of those. But it's a pleasure to finally meet, and hopefully this is the beginning of some fruitful collaborations. Because as Xavier mentioned, there's a lot of overlap and things that we're doing. This guy to my right is my son Lucas. He's a student at USF who is spending the COVID times at home with me, and he's actually in a data science program there. So he's joined us today to listen to what you have to say.
Welcome, Lucas. So awesome to have you here. Your dad's awesome, by the way, but you probably know that.
Thanks. Yeah, you should. Yeah, anytime you just call Xavier up, maybe you can compliment. That's good. Appreciate that. And so, so I'm as Xavier mentioned, just real quick, for those of you that don't know me, I'm an ocean scientist. I'm primarily a physical oceanographer, and I studied the kind of physics of waves and high winds and hurricanes and things related to climate change and how stuff moves from the atmosphere to the ocean. So for me, the world is like, it's about this interaction between these two fluids that we live in, the air and the water, and all the transfers that happen there, and a lot of fundamental things related to that. And so Holly, did you want to say anything to introduce yourself before we go, or are you going to just, okay, that's Holly. She says hi.
Yeah, as you see, I've got a son as well.
Okay, good.
I should bring my son and my daughter too. Go upstairs.
If it's hot, it's probably fine. That's probably yours. It's not hot. Anyway, so I am what's relevant here is I am a South Miami neighbor. So I live in the town of South Miami. That is actually probably mine, honey. Anyway, so, but I'm here because we are all going to be affected. We are all affected already. And we're all wearing many hats right now. So sorry. Anyway.
Okay, well, great. Thanks, Holly. Anyway, so to introduce Dr. Cairo, Alberto Cairo. He's a journalist and designer with many years of experience leading graphics and visualization teams in several countries. He joined the University of Miami School of Communication in January 2012, which is why I'm particularly, we haven't crossed paths yet, but like I said, hopefully we will shortly. And he teaches courses on infographics, or we are, but it crossed paths again, on infographics and data visualization. He is also director of the Center for Visualization, Data Communications, and Information Design at UM's Institute for Data Science and Computing, and a faculty fellow at the Abess Center for Ecosystem Science and Policy. Dr. Cairo has been described by Microsoft as always in the vanguard of visual journalism, and he is the author of the books How Charts Lie, Getting Smarter About Visual Information, Truthful Art, Data Charts and Maps for Communication, and The Functional Art, An Introduction to Information Graphics and Visualization. So I think I'm really looking forward to this. This is something that, as I think a couple of people mentioned, as a scientist, we're always trying to figure out how we can better communicate our message. And as Xavier mentioned, that it's a lot of it's to the audience, but we're frequently more and more directly tasked with trying to communicate beyond each other and to the broader community, whether that's by foundations that are doing funding or by the National Science Foundation, which is strongly pushing towards trying to bring the science to the community. So I think that even in a specialized domain such as science, we really need to understand better how to get our message across. So without further ado,
Well, thank you. Well, hi everyone, and thank you for inviting me. We are a relatively small group, so I guess that we can keep this informal. I'm going to show a few slides that, as Jamal said, we are going to share with everyone right after I finish speaking, and then I can stay as long as it is needed to have a conversation. No, I'm not in a rush to leave. I enjoy these types of conversations, particularly with like-minded people, because I do care a lot about climate change, and I care a lot about telling the truth. I mean, my second book is titled The Truthful Art. So what I care about the most when designing a visualization is to be as truthful as possible at presenting the patterns that the data may hide, and the messages that the data should reveal, right? So anyway, the title of the presentation that was proposed to me by Jamal is Data Visualization and Climate Change, but I'm going to go a little bit beyond climate change. I'm going to bring other examples that I think that can be, helpful to also think about how to talk to the public about climate change and the dangers that climate change may pose. So besides everything that Brian mentioned that I have done, I've been a journalist. I am a journalist. I consider myself above all a journalist. And I would like to explain what a journalist truly is, which is something that I also try to do at the beginning of my courses at UM, because my classes are in the Department of Journalism, but most of my students are not journalists. I have plenty of students from Rasmus, from the Abess Center, statisticians, data scientists, and I usually begin the course saying, this is a course about journalism. But journalism is probably not what you have in mind. Journalism is not the task or the job of working in a newspaper, right? A journalist is essentially anyone who cares a lot about a community and gathers information, processes that information, translates that information and filters it, and then presents that information for the benefit of the community that that person serves. That's what a journalist is. Therefore, if a scientist, for instance, a climate scientist or a marine scientist creates a blog, a weblog, for instance, in which this scientist translates the science to the general public in a truthful manner, presenting the data as it should be, the stories as they should be, in order to inform the general public about that science, that's journalism. So journalism is more like a frame of mind, more than a profession. And it's a way to look into the world in which you, again, try to provide service to a community, but providing the information that may benefit that community. Data visualization is part of this. Besides being a writer, I write books, I also visualize information. I also present information visually. I create both pictorial graphics, so I explain things visually. I use 3D models, but I also do data visualization. That's what I would like to talk a little bit about today. We are going through a golden age of data visualization. So data visualization is being embraced by scientists, by business analysts, by professionals from many fields. Also in the world of journalism, the visualization has been growing quite a lot in the past 15 years or so. In the world of news media, actually my PhD dissertation is related to that. Right? I did a historical exploration of how data visualization took over the world of news media, particularly newspapers. In the past decade or decade and a half, there has been an explosion in the use of data visualization in news media. Visualization even appears in the covers of magazines and newspapers all the time. Probably most of you are familiar with these, the warning stripes visualization that was designed by Ed Hawkins a while ago, and it became a sort of like an iconic a picture that has been printed on T-shirts and on cars, and people carry it in demonstrations, and it even appeared in the cover of The Economist magazine a while ago. It's essentially a heat map. This type of graphic is called a heat map. The colors and the intensity of those colors represent a quantity. That's the essence of data visualization, by the way. Data visualization is simply the transformation of quantities into objects whose characteristics vary in proportion to the data that is being represented. That principle in visualization, we call it the principle of encoding, right? You begin with some numbers, then you select some objects to represent those numbers, and then you vary certain properties of those objects according to those numbers. For example, in a bar graph, the property that varies is the length or the height of the bars, which varies in proportion to the quantities that you're representing. In a heat map, what varies is the color hue or the color shade of the objects that you have on the graphic, right? Now, why is data visualization becoming so popular in news media? Well, in part it is because news media are seeing, people who do the analysis of the data, of audience data in news media are seeing that data visualization is extremely popular. For many years, the most popular story ever published by the NewYorkTimes.com is a data visualization commonly called the Dialect Map. I don't know how you've seen this project, but it's a lot of fun. It's essentially a visualization in which you enter the site, and the site starts asking you certain questions, such as how do you pronounce this word, or how do you refer to this object? And based on your responses to these questions, it generates a personalized map, a customized map, which through the color represents where you are probably from in the United States. So the person who completed this survey is probably someone who lives on the West Coast of the United States. But the map that it generated for me, as you probably notice, I'm not a native English speaker. So the map that generated for me said that I probably lived in South Texas or in Miami, which is actually quite accurate. It told me that I lived in Miami. So it's a lot of fun. It was partly designed by a former student of mine from the University of North Carolina, Chapel Hill, years ago, Wilson Andrews, who is still at the New York Times. And it became super quickly, again, the most popular story ever published by the New York Times for many reasons. And I think that these reasons actually speak about things that we can take as sort of like inspiration to communicate climate science better. First of all, it's extraordinarily well designed. It is very beautiful. The UX, the user experience is fantastic, etc. But then it also engages the reader by putting the reader at the center, asking the readers questions, asking people to do something with the data. So it's not just a data dump. It's not just data presentation. It makes the reader do something in order to obtain data. And then it customizes the data to the needs of the reader. I call that in one of my books, the me layer. Where am I in the data? Don't show me just the data. Show me where I am in this data. One example that I usually put also is, let's say that you do a sort of like a curve of the wealth distribution in the United States, like a histogram, right, of the wealth of all families with a very long tail, obviously, because we have many billionaires in this country. If you show that curve, which is extremely skewed, that's interesting enough. But if before you show that data, you ask the reader, what is your current wealth? And then you add a line in the curve that says, you are here, right? You are, richer than 60% of Americans, but poorer than 40% of Americans. Just by the sheer fact that you have included that me element, engagement with that graphic will increase quite a lot, even if the data is exactly the same, even if the data doesn't really vary. Now, this is not the only case. The most popular story ever published by the Washington Post online is also a data visualization, which appeared this year, right after the beginning of the pandemic. They published a simulation of how a pandemic spreads in a population, depending on whether a country takes measures against that pandemic or doesn't take measures against that pandemic. They represent a fictional population of people through dots that pass the disease to each other. In just a few days, most popular story ever published by the Washington Post. But even more, the Washington Post this year disclosed that out of the 7 most popular stories ever published in their website, in the WashingtonPost.com website, out of the 7 most popular stories, 6 of them were graphics, were stories that were produced by the graphics department at the Washington Post, which, an aside, is also directed by another Spaniard who learned how to do infographics in the same place where I learned to do infographics, a newspaper in Spain called La Voz de Galicia in northern Spain. This is sort of like a happy coincidence. He's a friend of mine. In any case, out of the 7 most popular stories ever published, 6 of them were graphics. There's a huge power in data visualization. There is the power to communicate clearly, but there is also the power to capture people's imaginations through the data that we present to them visually. And we should take advantage of these. I'm a great believer, and Jamal knows this because he took my class. I'm a great believer in the fact that anybody and everybody could learn how to do good data visualization. Because when you can do data visualization and you pair that with good writing or with good speaking, you become a much better communicator. In any case, why do we visualize? Well, we visualize essentially because we human beings, a substantial portion of our brain is devoted to processing visual information. So we are very well prepared to absorb information that is presented visually. John Tukey, who was a famous statistician from the 20th century, who is considered one of the founders of the modern field of data visualization through his book, mainly Exploratory Data Analysis, which was published in the 70s. He said that the power of data visualization is essentially that the value of a picture, the value of a graphic, is that it forces us to see what we didn't see before, right? A visualization is essentially a tool that allows us to see patterns in data that we may not notice if we don't visualize those data, if we don't represent those numbers. Actually, the lesson that Tukey tried, and he was a statistician, he was not a designer, but he said that if you want to understand your data correctly, regardless of who you are, whether you are a social scientist or a political scientist or a physical scientist, etc., always visualize your data, because if you don't visualize it, there will be features of those data that will not be noticed. Now let's talk about climate change, right? And to prove that, right? So if I show you this data set, this is just a small portion of a data set, a very famous data set from the late 90s. It's a data set that shows the variation of global temperatures from the year 1000 up to the year 2000, measured in Celsius degrees and in comparison to the average of certain years of the 20th century. That's the reason why we have negative values and positive values. Now, if I just throw these to readers, right, readers will not see anything. They say, oh, I see all these numbers. I don't understand anything. What is going on, right? It's impossible to see, for example, through the table, through the tabular presentation of the data alone, whether temperatures increase or decrease throughout the years, which is a possible question that we could pose to these data. But answering that question, did temperatures increase or decrease in the past 1,000 years? It is impossible to do through the table. A table, though, may be useful. When is it a table useful? When you want to find out about one specific value or two specific values. So if, for example, you want to see what the temperature was on average in 1878, The table is good for that because you can go to the table, go to the corresponding cell, and you will see that number. But if you want to see the big patterns and trends that hide all behind these numbers, you need to represent your data. You need to transform those data into an object that makes the data almost physical. That data set that I showed you before was created by several climate scientists. It was originally published, this graphic was originally published in 1988, the famous hockey stick chart, and then it became extremely famous after it appeared in the IPCC report from 2001. So the hockey stick chart is, in my opinion, one of the most fundamental and also one of the most iconic visualizations of the 20th century, because it condenses in a very humble Excel design graphic, it condenses thousands of numbers and it reveals a pattern to the bare eye that was impossible to see in the previous data set. It also condenses not only the temperatures themselves, the point estimates of the temperatures themselves, but it also shows you the smooth of the data. It also shows you the level of uncertainty of the data, because obviously part of this data is based on proxy variables, because we don't have observations from the year 1000, obviously. So these are all reconstructions of temperatures. And it also reveals the main pattern of the data, which is essentially, so to speak, presented and is spoken as a layperson. From 1000 to 1900, global temperatures varied, but they varied within a certain range. But once we get to the 20th century, we have a sudden spike in global temperatures, a very sharp spike in global temperatures. That pattern, horizontal, almost vertical, it was impossible to spot in the previous visualization. This graphic also speaks about the persuasive power of data visualization, because once you notice this pattern, once you see this pattern, you cannot unsee it anymore. It sticks to your brain because it is so persuasive. However, and this is the challenge though, this is the whole reason I wrote a book that is titled How Chats Lie, persuasion goes both ways. So visualization can also be used to deceive the public. And I have tons of examples in my latest book, but I want to show you just one of them. This was a graphic that was tweeted out by National Review, which is a conservative publication a while ago. They wrote, the only climate change chart that you need to see. And they plotted a line chart of global temperatures from the year 1850, I think, up to the present. And we can see that there's no variation in global temperatures. I say, what's going on here? Well, what's going on, and the reason why this chart is so absurd, is that the scale of the chart goes from 0 up to 110 Fahrenheit degrees. And this is showing the global average temperatures, right? Many people made fun of this graphic because obviously the y-axis is so absurd, and it was chosen probably to minimize the variation, right? For instance, in my book, this is a screenshot of my book, Richard Rice, who is from the University of New York, added this annotation that I found super funny, putting those ranges over there on both sides of the chart, because obviously if you go 5 degrees above that line, basically what happens is that you had 200 feet of sea level rise, but if you go 2 or 3 degrees below that line, you have a new ice age. So the point that Rice was trying to make is that by choosing that very wide axis, basically what you're doing is minimizing something that is really important. I mean, a very small increase in temperatures may not sound like a lot. 1 point increase or 1.5 degrees of increase, it doesn't sound like a lot, but it's highly significant. Therefore, what I propose in my book is, instead of putting the scale from 0 to 110, which is a little bit absurd, will be to sort of like frame the data in a more meaningful manner, in a more reasonable manner, trying to actually show what the variation is by framing the data better. Because again, an increase of 1 or 2 degrees is extremely significant. Therefore, it needs to be made to look significant by exaggerating that scale. That will be the truthful representation of the data. Not only because of that, but also because the degree scale doesn't have a natural 0, and an average temperature of 0 is also absurd. So there are many reasons why the original chart is so absurd. So there are people out there who are trying to lie with graphics. There are also people who are trying to tell the truth with graphics. And I guess that if you're in this meeting today, you want to tell the truth with graphics. So what can we do, I think, if we want to produce graphics that are informative, truthful, and also more persuasive, that capture people's imagination a little bit more? I'm going to give you just a few tips, and then during the discussion, I can show you more examples, and I can go more in depth in some of these tips. As scientists, the first thing that I think that we could do, all right, that you could do, because I'm a journalist, I'm not a scientist, I'm a journalist. The first thing is to pay more attention to visual design. By visual, here I put two examples of graphics that I think that are wonderfully designed. The first one is by the Washington Post. This very big story where actually I got the I need to log in the Washington Post to show you this graphic because I visit it so often. Give me just 1 second. I'm going to stop sharing my screen so I can log in, and I will show you the graphic. So they published this story, basically explaining why climate change is real, right? And they provided all the evidence for climate change, and they presented the data using graphics of different kinds. Let me just this is my password. There you go. Okay. Now I can share my screen again. Anyway, so they presented the data with a combination of beautiful 3D renderings, maps, charts, video, photograph, animations, etc., showing all the evidence for climate change through the combination of visuals, graphics, etc., that have a level of visual sophistication that make the graphic looks so nice that it sort of captured your attention. They sort of captured your attention. So the point that I usually make in my classes through examples like these, or this other one that also comes from the Washington Post, is that the same way that we journalists who work with data all the time, we pay a lot of attention to matters such as typography, color, composition, white space, the words that we put in the graphic to clarify the graphic, and so on and so forth. That level of attention, I think, could be put also by scientists. Whenever scientists design charts or graphs to be included in research papers or in news releases related to research papers, that attention to detail, that attention to the design, to the visual design of the graphic, to the sophistication of the presentation of the graphic really matters. And this is a point that I usually stress quite a lot when I do workshops for scientists. In general, scientists tend, and I know that there are many exceptions to this, okay? So I'm being unfair by generalizing too much, but scientists tend to believe that visual design is sort of like the icing on the cake. They say, oh, I just want to present my data. So it doesn't really matter if my typefaces, if the fonts that I choose don't look that great, or if the colors don't look that great, or if my composition is not that great, because what really matters is the data. I just want to show the data. And the point that I usually make is that caring about style, caring about visual design is the equivalent of caring about good writing. If you care about good writing and you spend time polishing what you write or polishing what you say in a presentation that you'll give to the general public, you should pay equal amount of attention to the graphics that you present to make them look good. Why? Because, and this is something, a book recommendation here, there's a wonderful book written by Donald Norman, who is one of the founders of the field of user experience, titled Emotional Design. And in that book, Norman says, things that look good also work better. Right? So there is a connection between the aesthetical appeal of an object and how well that object functions. And he poses several conjectures as to why this may happen. He says that, for instance, objects that look great put us in a good mood. And when we are in a good mood, we feel more prone to using that object or to pay more attention to that object or to engage more widely with that object. So caring about visual design really, 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 really matters. And this is one of the things, by the way, that I spend more time on in my own classes, trying to help the students polish their designs, line things up correctly, add more white space, improve fonts, create visual hierarchy, pay attention to fonts that are readable, and so on and so forth. Those details really, really matter when you want to present an idea clearly. Also explaining the data, not just visualizing the data, but also putting yourself in front of the data and trying to explain it. There's a great example from the beginning of the pandemic by Brian Stelter, one of the presenters of CNN, who showed the famous flatten the curve graphic at the beginning of the pandemic, but he didn't just show the graphic. He showed the graphic and he put himself in front of the graphic and explained how to read that graphic, reinforced what the graphic said, emphasized the main stories that the graphic was trying to convey. Those words that we use to reinforce the message of a chart or to point out what really matters in a chart, we call that in visualization the annotation layer. And it's an extremely important component of any visualization. The annotation layer is the title, the intro, the little notes that you put here and there to call people's attention to particular points in your data. Those elements are incredibly important. I'm not the only one who says this, by the way. John Bourne Murdoch, who is one of the designers of visualizations at the Financial Times, which, by the way, is one of my favorite sources of great visualization. There was an interview with him a while ago, and he said that even if he's a person who works with data every day and engages with scientists and visualizes data all the time, in the department that he works for, what they consider the most important element of their graphics is not the graphics, is the annotation layer. Because the annotation layer is what may call people's attention to the points that truly matter in a graphic, or helps people not to miss an important feature of the data that is being presented to them. Now, I truly believe that we need to learn how to organically integrate visuals and text better. And this is one of the things that I try to instill in my students, and also I try to emphasize in talks all the time. I am also a great believer in learning by example. So one of the best examples of how to integrate words and visuals will be the work of Hans Rosling. If you have never heard of Hans Rosling, I greatly encourage you to look into his work. Rosling was a professor of international health in Sweden. He sadly passed a couple of years ago. And in my opinion, he was one of the best presenters that I've ever seen. Not only presenters, but presenters of data that I have ever seen. He was someone who integrated himself with the graphics that he presented. He was a scientist, he was a statistician, he was a medical doctor, but he didn't do in his presentation what most people do in their presentations, which is to put a visualization in the background and then cross their arms and say, you know, as you can see in my data, blah, blah, blah. But he said, when I interviewed him a while ago for my first book, for the functional art, he said, whenever I attend a presentation like that, I feel prompted to say, Rosalind say, I feel prompted to tell the presenter, I don't see it, show it to me, right? Point it out to me in the graphic. So he decided to start presenting data in a way that he integrated his own body with the visualization that he was presenting. Let me show you just one quick example. This comes from one of his talks. This snippet of video comes from a documentary that he made for the BBC in the UK, titled The Joy of Stats. By the way, all his presentations can be found in his website, gapminder.org. And before he passed, he wrote a book titled Factfulness. That's the reason why it appears here. In any case, that portion of the video of the BBC. Rosling appears on the screen and says, let me talk to you about the world. But first of all, let me tell you, there's going to be a vertical axis, and this vertical axis represents lifespan. Then there's going to be a horizontal axis, and this horizontal axis represents income, country by country. I'm going to talk about countries here, country averages. So if your country is down here, it means that your country in general tends to be poor and sick. But if your country is up here, it means that your country tends to be rich and healthy. So I'm going to start showing you the countries as they were in 1810 in the past. Most countries are going to be down here. So let's make them show up. The countries are going to appear color-coded by continent. So there's red, blue for Europe, and then the size of the bubbles is proportional to the population. So as you can see, in the past, most countries are down here. That means that on average, these countries tended to be sick, quite sick. Life expectancies were very, very low. And there were a few exceptions, like the UK and the Netherlands, who went above the averages of the world. But then if we start moving the world towards the present, we will see that all these bubbles will tend to move towards the upper right corner, meaning that life expectancies increase and the And also the wealth of people in these countries on average also tends to increase. There are obviously huge inequalities within each one of these countries, but on average, all of them tend to increase in life expectancy and tend to increase in income. And then during the presentation, he used his body, as you saw, to sort of like signify and emphasize drops in life expectancy. He stopped the animation at some point and he started talking about specific countries. You're going to see that. So he said, there is Japan, take a look at Japan. And as you can see, there's a group of countries down here that I have not. So he is sort of like overlaying a narrative on top of the visualization. So visualizing data for the public, this is important. When we want to present data to the public, we should not just throw data at people. We should try to help people understand what it is that they are seeing, by pointing out the most important facts of the graphic, by explaining how to read the graphic. Because as you saw at the very beginning, Rosalind began by showing no data. He first of all began by explaining how to read the graphic. There's an axis, there's another axis. The size of the bubble means something, the color means something. He was explaining the encodings before showing any visualization. Why he did this? My guess is that he knew that probably most of his readers had never seen a scatter, his viewers had never seen a scatter plot or had forgotten how to read a scatter plot. This is why this is so important, to explain to people what it is that they are seeing. And then we should also try to make data look less abstract. And I'm going to show you just a couple of examples. So a while ago, Reuters published a visualization of how much plastic is consumed in per unit of time, per second, per minute, per hour, per day, per year. And they didn't do this project based on traditional visualization forms, such as bar graphs, line charts, etc. They did it with bottles, like plastic bottles. How many plastic bottles are consumed since you opened up this project? So it starts adding a counter. So it counts a minute, right? Since you opened this website, right now, 200,000 plastic bottles have been sold, and it keeps increasing until it reaches 1 million plastic bottles. That's the average consumption of plastic bottles all over the world in 1 minute. And as you can see, but the truck that appears gets drowned in these plastic bottles. This is all, by the way, generated through a 3D program. I think that they used Cinema 4D to create this visualization. And they then continue by saying, well, this is the amount of plastic bottles consumed every hour. And they compare that to the Christ the Redeemer statue in Rio de Janeiro. Every day, that's the amount of bottles of water compared to the size of the Eiffel Tower. 1 month, it doesn't even fit on screen compared to the Eiffel Tower. And then in 1 full year, just impossible to comprehend. It's so large that is just enormous. And then in the past 10 years, you would cover essentially almost the entirety of Queens and Brooklyn in New York. That will be the size of the mountain of plastic bottles that you would consume. Now, analytically speaking, this visualization is not very accurate. Some visualizations are very good for accuracy. Bar graphs, line charts. When we want accuracy, being able to tell straight patterns and seasonality of the data and comparing things very accurately, traditional visualization forms such as scatter plots, bar graphs, line graphs, and so on, which are the bread and butter of my own work, are essential. But the point of this graphic is not accuracy. The point of this graphic is to punch you in the face. That's what it tries to do. Right, to provide an impact. So sometimes visualization can be used for these, to provide an impact, particularly if we later pair it with more traditional visualizations, right, with bar graphs and line charts, etc., that show you the data, for example, country by country. Another example of presenting the data in a more physical manner will be this famous video by the Weather Channel, in which they try to explain to people, what does it mean that you're going to be surrounded by 3 feet of water, or 6 feet of water, or 9 feet of water? You can visualize that through vector illustrations, and that's fine. I do that all the time. But in this case, they decided to create a virtual environment and actually show you what that looks like. I'm actually going to turn off the sound here so it will not distract me. So they begin with a traditional visualization, right? This is called a choropleth map, right? Map that uses shade of color to represent the data, but then they transition from the traditional visualization, the one that I create 99% of the time in my work, this type of graphic, they transition to a non-traditional data visualization in which they try to make the data feel more physical by putting, again, you, the person, at the center of the data and seeing how the water rises around you, right? That's 3 feet, that's 6 feet. That's what 6 feet looks like. It's impressive, right? It's much more impressive. I think that this is 6 feet. There you go. That's how what 6 feet looks like, right? When you say the number 6, it sounds relatively small, right? But when you see it, it's like, ooh, careful here. This is actually quite a lot. There is a phenomenon, by the way, that we, people who work in visualization design, deal with all the time. And we call these quantitative numbing. Quantitative numbing is essentially that we human beings have a very hard time understanding numbers, particularly if those numbers are very large. This is related to the old saying, 1 death is a tragedy, 1 million deaths is a statistic, right? We don't feel 1 million deaths. We actually may feel more by 1 death because we can sort of like relate to 1 death. We can imagine 1 person dying, but 1 million people dying, we cannot really relate to that, right? For us human being, any number bigger than 100 or than 1,000 sounds like a big number. But for most people, for example, there's no difference between 1 million and 1 billion and 1 trillion. The 3 of them are big numbers. That's quantitative numbing at work. And we could try to fight against that through visualizations such as this one, for example, by trying to make the data a little bit more physical, or also by putting the reader at the center, circling back to the theme that I spoke about at the very beginning. I'm going to show you the latest project that I art directed. It's a project that was published by the Washington Post a few months ago. It's titled At the Epicenter. And it asks the question, what if all deaths of COVID-19 had happened around you? What if everyone who died of COVID-19 in the US were your neighbor, right? How big the circle around you would be? It's as simple as it gets, but it's probably one of the most successful visualizations that I have ever worked on. Because it really had a huge impact in social media, news media. It was published both in the United States. The Washington Post published the United States version, but prior it was published in Brazil with Brazilian data as well. And in Brazil, it got picked up by the biggest news program, but it was retweeted by celebrities all over Brazil, etc., because people actually saw how big the catastrophe was. When we say 250,000 people have died of COVID-19, that sounds very abstract. But when you force people to visualize those numbers as if they were their neighbors, and you reveal how big the circle around them would be, something clicks in the brain of people. So this is the way that it works. It's super simple. You just go here, you enter any address. This will be in the crossings in West Kendall, right? So it tells you, you are here, right? I'm literally here, right? That's where I'm sitting right now. That's me, right? So this is in your neighborhood. On February 29th, Washington State reported the United States' first death from the novel coronavirus, a man who was 58 and who lived in Washington State. But just for the sake of argument, let's suppose that this person was your neighbor. Or let's suppose that is the guy that you see next door every day on your way to work or whatever. These dots that you see over here, this is all census data. Each dot represents 1 person who lives around me. So this is the first death of COVID-19. Now let's suppose 1 week later, almost 100 people had died. And this is how big the circle would be if 100 people had died around you. So that looks like a lot. It's almost my entire block. And then 1 month later, almost 13,000 people have died of COVID-19. I actually can show you the streets here. I can click on show labels. So this is 124, 137, and 127 Avenue, right? So this is how big the circle will be just 1 month later after the pandemic started in the United States. And what about now? This is not updated yet, I think. So it only goes up to 206,000. This was updated a few weeks ago. But this is how big the circle will be around you. And all of you live in Miami or are familiar with the geography of Miami, maybe not Kendall that well, but this is an enormous circle. It will be 3.1 miles or 5 kilometers if you're a European of radius. That's gigantic. That's gigantic. When we present data this way, when we force people to see the data not as it is, but we try to create an analogy of what the data looks like, something clicks inside our brains. Now, this is not a substitute for traditional data visualizations, by the way. I'm not saying that we should use this type of visualization and not line graphs and bar graphs and maps, etc. We should use those. Those are primary. But everybody had done already traditional graphics about COVID-19, right? How many cases, how many deaths, where the deaths are happening. We can try to provide a different angle through which we can see the data. So what types of analogies, what types of metaphors, such as this one or many others, could we use to present data related to climate change better to people, for people to understand the impacts of climate change? Sometimes when I see graphics related to climate change, they sound very abstract. This is going to happen 30 years from now. I don't even know if I'm going to be alive 30 years from now, but it's going to affect my children. And when you force me to think about my children, something may click inside my brain. So is it possible to come up with metaphors similar to this one to communicate climate change to people a little bit better? It might. And this is all related to what I consider the main purpose of my work. And I'm going to close the presentation now. So for me, visualization is not what philosophers could call an ultimate value, right? Or an ultimate goal. For me, visualization is an instrumental value, is what leads me to something that I care about more, which is understanding. I want people to understand things. I have devoted my life to translate things. I get things from scientists, I translate them, and then I present them to the public. And the more people who are engaged in this way of thinking and in this work of translating complex information to the general public in a fair, truthful, and understandable manner, the better off we will be. I think that more and more we can help other people, we can help communities understand numbers better, and through those numbers perhaps understand the world that surrounds them a little bit better. In any case, that's all that I had for today. Again, we are going to share the slides later. We can do it through the chat window even. We're a small group, so I guess that I can do that while we have a conversation. So again, thanks again for having me. I'm going to put the PDF here in the chat window if I can. Yes, I can. There you go. There it is. And now just ask whatever I can help you with.
Well, that presentation was really, really incredible, and I think it's timely. Jamal, who, as you know, is a master's student and is interning with us in this project, one of his tasks is to create a resource page that goes beyond Pinecrest, that allows us to visualize sea level rise across our entire county. Again, we had this little problem called the virus, but last year we were going to put a flag in every school. We got the data for the elevation of every single school in Miami-Dade County. And we're going to put a visual there where kids were going to plant mangroves, which of course grow in the water, alongside a flag that talked about the elevation of that school, how long before the water hits the school. So that program is called Plant, obviously. We have not done anything with it. In fact, all the plants,
cool idea.
All the plants are in my orchid house because couldn't give them to the schools.
Yeah.
But I also asked him, and we got the data for the 20, I think there's 33 municipalities alongside the county in Miami, as a way of creating those visualizations at the city halls, like what is the elevation at City Hall. And what I'm trying to do is the same way we mapped the topography of a relatively safe community. We picked this community because my studio is in Pinecrest Gardens, and we did it in partnership with the garden. But my big concern, and I'm inspired by your New York Times coronavirus radius, people have died there. What I care mostly about in this project is about the people who have no idea that they're going to get hit. And very briefly, I say this probably at every Underwater HOA, but we're generally not going to be okay, but some of us are going to be more resilient than others. And that, of course, has to do with individual wealth, but also municipal wealth. Miami Beach can adapt. They can put pumps and elevate because they have the tax base to do it. Your neighborhood, west of you, especially, doesn't. Like there is no income.
Or to the south of me, Homestead.
Homestead, West
Yeah.
Sweetwater, Hialeah, anything that is not coastal, ironically, or dense, right? So suburbs that are at the edge of the Everglades aren't going to be saved in my mind in the years to come, and people don't get that. So what I need to do is Underwater HOA across the western part of our county, of our 2.6 million person county. Well, it's an ordeal. I mean, we don't have the resources to organize and mobilize neighborhoods, especially when they don't see the problem. That's what the whole thing is. So I'm looking at data visualization as a way of mapping the topography, and I'm very inspired about the personalization aspect of it. So just as you were talking, I was thinking, oh my God, what if, we literally, so we have apps that map, you put your address and it tells you what your elevation is. You have to be proactive in getting there. But as a way of inspiring you to do that, maybe you look at your general elevation. Is your neighborhood going to be sunk or not? And I think that the same way that this platform that we're using here to communicate big ideas, whether it's visualization or how climate is making hurricanes stronger and slower and wetter. This becomes, I think, a platform, a resource platform, so that neighborhoods can self-organize and do this kind of work. And I'm just interested in figuring out how to do that in the best way. I know that Brian said this when he started this meeting. He said, it's no longer just about us talking among ourselves. And I did so the day after Election Day, last meeting in November. We need to start looking outwardly, and each of ourselves, being the protagonists within our own separate neighborhoods to effectuate this change. And I think as an HOA,
I'm going to interrupt you in there. I mean, that's one of the reasons why I highlighted the friendly voices, the person who presents the data. Because again, it's not just the data. If we just visualize the data, the people who are going to consume those visualizations are the people who already know that there is a problem and who are engaged enough to consume the visualization itself. But when you have the visualization and then you have a friendly looking and sounding person who shows you the visualization and then explains the importance of that visualization, someone who sounds non-political, non-partisan, friendly, smiling, fun, etc., 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 the message of the visualization suddenly becomes more persuasive. That's why Rosling was so powerful in his presentations, because he was fun. He was someone who was capable of making you laugh looking at a visualization, which is sort of like crazy. It's like, I used to say that he was able to make data sing and dance. That's what he did. He actually danced in his presentation sometimes. So I would like to see hundreds of Roslings everywhere doing something like what he did, which is to like keep using visualization, but don't stay at the visualization level. The intervention cannot just be visual. It cannot be just a flag. It should be also a person talking to you about it and pointing out what really matters. The human voice, the human connection really matters. So members of the community who are capable of doing this, that would be the way to spread the word, but always backed up by the visualization, because at some point you need to present the evidence. You need to explain the data. You need to explain the numbers. The other challenge also is that, and we have all faced this, right? There's going to be also a certain portion of the community who is going to be super hard to persuade, just because, unfortunately, in this country, and it's also happening in those countries, a substantial portion of the population, they are impermeable to facts. They live, and sorry to be so blunt, but they live in an alternative reality created by a conglomerate of media who are trying to, first, it's a grift operation. They're benefiting from people's ignorance and they are feeding that ignorance. So how do you break the barrier? Again, I am a great believer that facts will not do that. We have a ton of evidence from cognitive science showing that if you have an unpersuadable person, and you show them more data, what they will do with that data is to co-opt the data to reinforce their misguided beliefs. You will not persuade them with numbers. You need the friendly voice, the non-partisan voice, the fun voice who can explain to them that in that manner.
In the underwater HOA, the idea is the neighbor. It's the neighbor who
The
puts
neighbor, yeah, your
sign in
neighbor
their
who
front
speaks
yard
to you.
and then
Yeah.
inspires the neighbor across the
Yeah,
street.
the neighbor across the street, but always backed up by the numbers. You do need the numbers, but first of all, you need the punch, and the punch could be the neighbor, the punch in the good sense of the word.
So my question to you is, how do I, work with this wonderful team here to, in this digital age and clearly on this digital platform, because we do not have the capacity to go to all these neighborhoods. We don't have the funding. We're all volunteers. This is nothing, this is totally self generated and operated. How can we leverage the power of data visualization to emulate what we did personally by hand painting signs and putting them and then having those conversations on a digital platform with the hopes that there is some existing homeowner group that we can infiltrate, like an actual homeowners association, so that they themselves, already established, already trusted, can be the people who perpetuate this? Is there you did it, masterfully by working with something we already buy into, the New York Times. So it's easy for us to go in there. But if you're not embedded in the community, do you have any digital online ways of?
Unfortunately, I that's something that I cannot really help with. I'm just a graphics person. I mean, I have some ideas, such as, for instance, one of the ideas that I have for the near future is an educational program about data science, not about climate change, but about data science, to teach data science to children. So actually propose to local schools, particularly middle schools and high schools, a short workshop about data science for high schoolers, to teach them data science in a fun way, in a non-threatening way, right? It's like, let's begin with the graphics. Let's visualize a distribution about a fun topic, obviously. And then through that visualization, through the graphics that you can generate, explain, essential elementary notions of descriptive statistics. This is a mean, this is a median, this is a mode, this is standard deviation, blah, blah, blah. But you begin with the non-threatening elements, right? You begin with the visuals, you begin with the graphics. So I wonder whether it might be possible to do that with you're already working with the schools, but could you go a step beyond that and actually propose teaching a class or something, and give materials that could be shared at home with the parents? I don't know. This may sound like something silly, but I honestly don't.
That's how we do it. I work through those.
Yeah.
You work through host mechanisms. And
exactly. The challenge is, though, that the person who makes decision at home is a parent. So how you reach the parent, that's the key thing. So I don't know, community groups, I honestly have no idea. I wish that I could help more with that.
I mean,
all that I can do is to help to produce better graphics, like more nice looking charts and maps that I can help with. Yeah.
No, Xavier, just to, kind of pitch in, and not to shameless plug, but the Cortado Science Art Academy is kind of what we're talking about here. And Dr. Cairo, you would not have heard of this academy that we're attempting to launch out of Pinecrest Gardens, but it is an outdoor COVID-friendly environment where I, as Xavier's studio manager, would also be the lead instructor of this academy, talking about using art to communicate science, and really diving into creative problem solving and leadership skills and building empathy. And so this is definitely a way of contacting the parents in that we're dealing directly with their students. All of this has yet to come to fruition yet. We're ideally starting that in 2021. But Xavier, just to kind of tell you as well, in terms of this brainstorming, the academy can definitely come into play here.
Absolutely. Yeah. Those students can be those fun faces communicating the data.
Friendly and young, and I think that will be the way. Again, charts are essential, data is essential, evidence is essential, maps are essential, but without a human face or some sort of attachment or some sort of like punch that gives you in the face, some sort of like physicality to the data is not persuasive, unless that it is something as powerful as the hockey stick chart, and you understand what the hockey stick chart truly means, because the pattern is so evident that it makes you stop and look at it, right? But those are the exceptions. They are not the rules. In most cases, data sets don't have that clear of a pattern. They are much messier. and the patterns need to be uncovered for you. They need to be explained to you. That's what Rosalind did in his presentations.
Can I say something real quick?
Of course.
So thank you very much, Alberto, for the presentation. It was amazing. Sorry that you all can't see me right now. But
You're very dark, Inigo.
But something so incredibly important that I thought you said, a key word was non-threatening.
Mm-hmm.
Right? Because everybody here is a sort of active environmental activist, and that implies dealing with an incredibly threatening fact, right? And it's very, very often portrayed from the lens of disaster, of apocalypse, of death, inequality, increase in all sorts of problems. And I think it's such an incredibly important idea to approach it from a non-threatening perspective, because when you do it from a threatening perspective, a large amount of people shut off to it.
Yeah, there's tons of literature. Let me interrupt you in there, and then I will ask you what the question is, and we can continue. But I tend to forget very quickly thoughts that cross my mind. If you're interested there's a lot of literature about persuasion out there that you could employ. So there's even a famous bestseller from years ago called Nonviolent Communication, which could be super useful. And there is a lot of literature from cognitive psychology about persuasion. There is a short ebook by a British psychologist called Tom Stafford. I'm going to write his name here in the chat window, Tom Stafford. And he wrote a short ebook collecting some of his papers about persuasion called For Argument's Sake. So if you can find For Argument's Sake that, and then you follow the bibliography and his papers, that will open the door to, it's a rabbit hole, because you will find other readings that can help you. But he provides very specific tips about how to be more persuasive. So for instance, but there's another book, by the way, I used the word before, unpersuadable. There's a book titled The Unpersuadables, which it's a book by Will Storr, I think, Will Storr, which is also about persuasion, The Unpersuadables. Persuadables, sorry, I'm not very good at English spelling. So this is another book about, and it talks about how to persuade an unpersuadable person, how to have a conversation to someone who is impermeable to the reality of climate change. And obviously you never begin by throwing data at them. And one of the strategies that Stafford uses that proposes in his papers is begin by having a conversation. Oh, do you think that all this climate change crap is like a Chinese hoax? Right? Why do you think that is? Explain it to me. I'm so interested. And be having an open conversation about that. And have the person explain reasonably where that belief comes from, which is one of the best strategies also to start doubting your own opinions. So we all tend to believe that our opinions are founded on sound reasoning and have solid foundations. But when you have to explain to someone who disagrees with you where an opinion that you have comes from, you become more aware of how flimsy the foundations of our opinions truly are. And that is when you can insert the evidence. When you plant the seed of the doubt in someone's mind, that is when you can start inserting the facts. Anyway, Inigo, I interrupted you. But I didn't want to lose this thought, because I think it was relevant to what you're doing.
No, I didn't have a question. I mean, that's exactly what I hoped for, I think, because it was less a question and more a comment in hopes of, talking about something and moving the discussion forward. So, yeah, amazing. Thank you.
Yeah. These are one of the things that I talk a little bit about in my books, because I'm also interested in these, how to make things more persuadable. When you know that you have a truthful message and that you have been rigorous or collecting the data and talking to sources and providing a message that is fair and truthful, how you can make that message also more persuadable. Obviously, these strategies can also be used for ill, as I was mentioning before. You can use it we can use these strategies for propaganda also, to push propaganda. But none of us wants to push propaganda, and that's what makes it different in our case.
Dr. Cairo, I'm curious, do you have any estimate? You showed us the New York Times and the Washington Post and how those were, some of the top articles were these graphics. Do you know this is like part A of my question. Do you know generally what the viewership was, like in what range they were reaching?
In the millions. Those stories, millions of people. The Dialect Map by the New York Times is still generating traffic today.
Yeah.
Today, almost a decade after. I think that it was published in 2013, if I'm not wrong. So 7 years after it was published. And they are not the only cases. I just show the Washington Post, but if you, for example, the Tampa Bay Times, they publish sometimes data visualizations. They won a Pulitzer Prize with a visualization years ago about inequality in schools in Pinellas County, and that won a Pulitzer Prize. And then their 538, for example, 50% of their traffic comes through their visualizations. But obviously they are a very data-driven operation. But in terms of absolute numbers, I don't know what the absolute numbers really are. I only know about percentages. For instance, ProPublica, which is an organization in New York that does investigative reporting. I have many friends who work there, and they told me that around 30% of their traffic, of their entirety of the traffic, 30% comes through the visualizations or through the databases that they have, 30%. Is enormous. That's gigantic.
So I'm curious then, I guess the reason that I'm asking is because I feel like data visualization is underused in short form videos. And I feel like right now with social media, with TikTok, Instagram, YouTube, that's where, obviously there's lots of people that are reading the New York Times and the Washington Post, but there's a ton of people, I would argue much more, that are, on these applications.
Data visualization combined with video. If you want to see more, just do the following exercise. Go to YouTube and search for the terms inequality in America. The first result, or one of the first results, is a data visualization in video format, in a narrated video format, and super well done, super well produced, and very, very well made. So it's underused, and I think that we could do it more. TikTok, animated GIFs, for example. If you want to, again, I'm a great believer in taking inspiration from tons of different sources. So that video about inequality in America will be one of them. Another one, funnily, also about inequality, is a documentary made by Robert Reich, the former Secretary of Labor from the Clinton administration.
He runs Inequality Media, right?
He runs Inequality Media. He draws things on a board, etc. But he made a documentary, and I don't remember the title. It's also related to inequality. So Robert Wright, Inequality something. So that documentary, I think that it is exemplary in the way that it combines a friendly looking presenter with animated data visualization. Obviously, in this case, it's a very partisan looking to certain type of viewers, presenter. But the techniques that he uses to present the data, they are very, very, very well thought of.
Yeah, I follow him on various platforms. He's
I like the way that he presents information. I think that he's a great presenter, very engaging speaker, etc. I really like how to explain things verbally and visually, and combining words and visuals. Yeah.
Okay. Thank you.
One more good one is the story of stuff. That was
I
the
didn't
first.
see that one. The story of stuff. I'm going to look for it.
I think it's the first visualization in video form that really got me.
Oh yeah, I'm seeing it right now with cartoon illustrations, cartoon animations. Yeah, cool.
And it basically, for anybody who doesn't know, it's basically the story of the life cycle of all of the consumer goods that we use.
Mm-hmm.
And it's really, really interesting. But I just wanted to make a comment about the perspective that I've gained as a student of yours, and how the little details really require an investment, but the return on investment is huge. And one thing I noticed is that a really well-designed visualization doesn't actually bring to mind in the viewer any of these little things that would come to mind if something was off about the visualization. Like, you would notice if it was off, but if it's not off, it just flows seamlessly and you don't even think about it.
Mhm.
And that's-
Little details matter a lot because a misplaced element, an inconsistency, a typo, they distract you from the main point of the visualization. That's why the small details matter.
Yeah.
They do matter a lot. Yeah.
Yeah, I guess I just had one thing as sort of in my own world of advising students. I'm particularly pleased to hear you confirm one of the things I've been harping on for the last number of years in the scientific. There's a move towards in PowerPoint presentations these extremely dense multi-layer plots that take about 15 minutes of staring at to really digest, and people would be throwing them up one after another in a presentation. I'd be telling my students, no, don't put anything up. You're not going to take the time to explain in detail what you're showing. There's no way you would take your entire 15 minutes just to explain this plot to make people understand it. Please, have a reason for showing the figure and explain what you're doing to people. And that's been something that graduate students in particular, there's a tendency just to flood everything they did onto the page.
Show everything. Yeah, show everything and people see nothing. When you show everything, people see nothing. That's a problem.
Yeah. So thank you.
Sure, absolutely. I mean, I teach students all the time how to, this is one of the topics of the class, is how to redesign or polish a graphic in a way that you don't lose that much detail, because that's also important. When you're presenting scientific data, you don't want to just show a gross average. You want to show the data in some level of granularity, just because you may have a skewed distribution or whatever, right? You want to show detail, but at the same time, there are techniques that you can use to make that data more presentable and more understandable. So if you have a hyper complex plot, you can certainly show it all in a PowerPoint presentation, but then the next slides, what they could do is to gray out the entirety of the plot, make it semi-transparent, and only leave a portion of it visible. And then talk about those portions. One slide, one portion, then another portion, then another portion, then another portion. That's just a traditional technique in narrative. You just split the information up step by step, and then you overlay a narrative layer. You put yourself in there and you talk about the data, you talk about the information that you're showing. Don't just
of course,
show.
in fairness to my students, some of them that are more adept at the visualization and the presentation,
But
showing me how to do that.
Yeah, and also in fairness to these students, these skills, and Jamal knows these, they take a lot of work to learn and to internalize and to practice with them. So it's normal. I mean, it's just science students spend their time learning science, not communication skills, which is another completely different skill set, which requires practice. It's a craft more than a science, right? So it takes a lot of time. So that's what I usually try to do when I teach workshop to science students, is to try to condense all these in like 5 or 6 hours. But then what I do is, and I can actually show you an example that I sometimes use in these types of workshops from Erasmus students. I did a workshop years ago at Erasmus. I did another one recently, but I ask always the students to send me examples of their work, either PowerPoint presentations or research posters or whatever. This is one of them, one of the posters that I received, and I redesign them. And I use the redesigns to explain to students some graphic design principles, right? In this poster, for example, I said, it looks a little bit text heavy, but the reason why it looks text heavy is not that it has too much text, is that the text has not been formatted. If you start adding some type variation, highlighting certain things over others, the text will not look that heavy. I also pointed out the scale on the map there on the right, that it has too many tick marks. You don't need that many tick marks in a map like that. I pointed out the bar graph on the right-hand side, the diagram in the middle, right? That triangle in there. I actually joke with the students that one of the things I say this in class all the time, I hate to be able to tell what software tool you use to design a particular graphic, because I don't want to feel that the graphic was generated by a software tool. I want to feel that the graphic was generated by a person who took the work to make the graphic look better, right? In any case, I use these, I spend like 10 minutes over every single point that could be improved in the graphic, and then I show a quick redesign. based on of the same poster, showing the exact same amount of information, the exact same amount of data. I didn't reduce the amount of data here, the amount of detail, but just by making what we could call cosmetic changes to the design, increasing white space, improving margins, improving the look of the diagram in the middle by adding a pictorial element that makes the graphic look a little bit friendlier, by adding an animal of some kind or something like that, polishing the map, polishing the bar graph on the right-hand side. You make the poster convey the exact same amount of information, but it not only looks better, it also works better. I bet that it is much more likely that people will read these than they will read that, because this looks very threatening, very dense, but it can be made to look much less dense. This is the reason why I said before that design really matters. Design is not an afterthought. The visual design is not the icing on the cake. It is an essential component of a good message. It's like when we write, the style of writing is not the icing on the cake. The style is the content also. It's part of the content, because the style conveys something about the message that you're trying to convey as well. And caring about the elegance of the style really tells something about you as a designer, but it also makes your project, your product, friendlier looking and much easier to read and more inviting without losing depth, which is always the key, to try to balance that out, right? The aesthetics with the depth that you can provide in your project.
Yeah, it's really amazing watching you critique our projects in class one by one by one, and the little changes that you make.
And how exhausting that can be. Because I really go one by one, 40 projects, one after the other, one after the other. Yeah. And I sometimes, as you know, I redesign them in front of you. I record video lectures in which I take a student project, I open it up and I start moving things around and changing styles and fonts, etc. It's crazy, yeah.
Well,
yeah, go ahead, sorry.
No, I was saying in the context of climate change communication, you know, the trick, going back to the audience that needs to be convinced, you know, what comes to mind is how important it is to create a graphic that's actually going to speak to them. And these little details, you know, the difference of having a readable, pleasant graphic and not, that's going to make such a huge difference.
Or the addition of an illustration, or a friendlier looking color, a little bit more white space so people don't feel that the information is too dense. All those elements really matter. Again, that style is not an afterthought. That style is essential to your message. It's essential to the communication act. That's why emotional design, I think that is such a great book to understand this principle. Beautiful things look, it's not only that beautiful things look better, beautiful things work better. Mm-hmm. All right. I guess that is almost 3:30. We're 1 hour and a half in total.
A great mic drop there. Beautiful things work better. So.
All right, guys. Well, thank you so much for having me. It was a pleasure. I hope that it was helpful.
Yeah. Thank you, Dr. Cairo.
Yeah. Okay.
Yeah, very grateful to have you here. Thank you. And let's all get together at some point. You know, Brian wants to meet.
I would love to. Yeah.
So do I.
Yeah. I have
the three of us can connect. You know?
I'm waiting for the vaccine to be widely applied, so we can start actually having like regular meetings with people face to face at some point. But yeah, absolutely.
Please.
All right.
Good night.
Take care, everyone. Have a good night.
Good night.